Good morning, students. Today we will start from page number 32. One topic was left there. Dalton's Atomic Theory, Chapter 3 of Chemistry. John Dalton gave theory which was termed as Dalton's Atomic Theory. According to him, whether it is a compound, whether it is a mixture, whether it is an element, they all are made up of a very small particle called atom. So students, you will be learning Dalton's atomic theory given on page number 32. The first postulate of Dalton atomic theory is each and every matter, solid, liquid, gas, is made up of a very tiny particle called atoms. Second point, according to Dalton, atoms are indivisible particle. That is, you cannot break them further. And according to him, mass cannot be created or destroyed in a chemical reaction. If you remember, that is what we explain in law of conservation of mass based on this postulate. Then third, he said atoms of a given element, for example, there is an element oxygen or an element hydrogen, sulfur, carbon, gold, any element. So the atoms of all that, for example, it is oxygen. So atoms of element oxygen, they all will have same mass and same chemical properties, which will be, according to this fourth postulate, which will be different from different element. Means, for example, if it is hydrogen, so all the atoms of hydrogen will have same mass and same chemical properties, but that will be different from other element, say oxygen, nitrogen, sulfur. So same element, same properties, and different element, different properties. Then he said that atoms, they combine in whole number ratio to form compound, from where we have developed the definition of compound, that atoms combine in whole number ratio to form a compound. If you remember, I have already explained compound and mixture topic in chapter 1. Then in chapter 2, then sixth postulate, he said that the sixth point, that in a compound, when we combine fifth and sixth postulate, we get definition of compound. According to him, in a compound, the number and kind of atoms in a given compound are always constant. Students, if you remember, I had already explained you that if we take a compound carbon dioxide, or if we take a compound water, so according to sixth postulate, the number of atoms, right, the kind of atoms and number of atoms of each element in a compound is always constant, same. Like I told you, water will be formed only when two atoms of hydrogen combine with one atom of oxygen in ratio 1:8. So that was explained by Dalton theory. So there are 6 postulates, students. Most of the postulates we follow, but there are some changes in some of the postulates which you will be doing in senior classes. One change I can tell you, the second postulate, that atoms are indivisible particle, but later on it was proved wrong. But this point is correct, that mass cannot be created nor be destroyed in a chemical reaction. So that was Dalton's atomic theory. 3-mark question. Okay. Now, students, take out page number 35. How do atoms exist? I told you in my previous lecture also, atoms of most of the elements, they do not exist independently, alone. Some of the elements, like, you all know the names, like it is helium, it is argon. I hope you have heard these names. Neon. So these are few more. So they are some of the examples of elements which exist independently. They exist independently, alone. Like you can see, one helium, one argon, one neon. But most of the atoms, they don't exist independently. They exist either in form of molecule, which I will be explaining you, the form of molecule, or molecule, or in form of ion. In form of ion, right? Now first is, what is a molecule? Student, the definition is given on 4th line. But in simple term, I am explaining what is a molecule. Molecule is when atoms of same element or different elements join together, they form molecule. Like I will explain you with this example. For example, hydrogen, H2. So how many atoms of hydrogen are there? 2 atoms, same. 2 atoms of same element combine to form hydrogen molecule. Right? For example, ozone. I hope you have heard this term, ozone. So 3 atoms of same element oxygen combine to form ozone molecule. So either atoms of same element like in this, or atoms of different element like hydrogen, oxygen combine to form what? A molecule of water. Like here you can see 2 different elements are there, hydrogen and oxygen. Here similar were there, 3 atoms of oxygen, same element. Here different elements are there, they combine to form a molecule. So the definition is given on page number 35, line number 4. You can mark from there, right? So student, now page number 36, right? So I hope you have understood molecule of elements, same element, right? Or different element, right? So molecule of element, like they have given example of oxygen. A molecule of oxygen consists of always 2 atoms of oxygen. Oxygen molecule never exists as O. You can never write in a reaction O. It will always be O2 because it never exists independently. It always combine in form of O2. So 2 atoms are there. It is diatomic. Di means 2. Then I have told you earlier example of argon, helium, they all are inert gases, right? So one molecule contains how many atoms? One molecule has only one atom. One molecule has only one atom. So they are monoatomic. Mono means one. One molecule has only one atom. So they exist independently, alone. Only few elements are there, right? And some like O2, N2, H2, oxygen, nitrogen, hydrogen, they always exist in which form? Diatomic molecular form. Di means 2. How many? What? 2 atoms in a molecule, right? So now very important term, students, to be learnt, that is atomicity, right? Atomicity. What is atomicity? Atomicity is number of atoms in a molecule. Number of atoms in a molecule. For example, I have written ozone. So question is, what is atomicity of ozone? So you will write 3. Oxygen. What is atomicity of oxygen? So count number of atoms. Always they will be, you cannot change it. Always it will be 2. So atomicity is 2. What is atomicity of hydrogen? So atomicity of hydrogen is 2. Of nitrogen it is 2. So different molecules have different atomicity. Like atomicity of phosphorus, it is always 4. Right? What is atomicity of carbon dioxide? So you add how many atoms of carbon? 1. How many atoms of oxygen? 2. You add 1 plus 2. The atomicity is how much? 3. Atomicity of carbon dioxide is 3. You cannot change. It is fixed. So student, on page number 36, table 3.3 is given and you have to learn the atomicity. Mono means 1. In one molecule, how many atoms are present? 1. Only of inert gases like argon, helium. In some of the molecules, like you can see, in one molecule, how many atoms are always present? Oxygen. So oxygen is always written as O2. Hydrogen, H2. Nitrogen, N2. Chlorine, Cl2. You cannot change it, right? Then some of the molecules which have more than 3, they are known as tetra. Tetra basically means 4, right? Tetra means 4. So phosphorus is written as P4, right? And more than 4, it is polyatomic. Poly means many, more than 4. Like sulfur, it is always occur in molecular form as S8. Atomicity of sulfur is S8. The students, please do learn this, that in their molecule how many atoms are present, which is its their atomicity, because you will be using it in this chapter later on while solving numericals. So do learn this. Monatomic 1, only few elements are there. Diatomic 2, tetra 4, poly more than 4. The most common example is sulfur, written as S8. So that was molecule of element, where atoms of same element combine. Atoms of same element combine. Now students, molecules of compound, as the name indicate, I have told you, definition is given there. Atoms of different elements combine in definite ratio to form molecules of compound. Which is definition of compound? If you remember, I told you, either same atoms combine to form molecule of element, or different atoms combine to form molecule of compound. CO2, H2O, SO2, ammonia, right? They all are example of molecules of compound, right? Some of the examples are given on the same page. Water, H2O. So two elements combine, hydrogen, oxygen. Ammonia, NH3, nitrogen and hydrogen. Carbon dioxide, two elements combine, CO2. So that is molecules of compound. Right, student? I hope you have understood this. Thank you, students.